Okay, good morning, ladies and gentlemen. This is again Professor David J. De Los Reyes. Okay, my next topic will be, since it's New Year, we will be more active. Okay, my topic for this morning will be a random topic, and this will now be a topic on algebra, that is on the so-called solution of system of linear equations. This is an easy one, but I just would like to emphasize how we solve system of linear equations using the so-called elimination by using the so-called elimination. Okay, let's proceed. We are given a problem. Solve the given linear equation using the so-called elimination method. The problem specifically specifies that the solution should be by elimination. Because in the so-called solution of system of linear equations, there are three solutions maybe. Solution by elimination, solution by substitution, and solution by using determinants or by using matrix. Okay, but for this illustration, we will be using the so-called elimination method. Okay, the given equations are these. Equation number 1, 5x plus 3y equal to 19. That will be equation number 1. And 2x minus 5y equal to 11. And that will be equation number 2. This is an easy one, but I just would like to emphasize how we perform the concept of the solution of this one. That's the most important thing here. Okay, let's try to bring out the solution. If we try to inspect equation number 1 and number 2, okay, we'll try to eliminate x and solve for y. So our method of attack will be to eliminate x and solve for y. That's why the solution is elimination. Eliminate. You eliminate one variable, then solve for the other one. It could either be that you eliminate x, then solve for y, or eliminate y and solve for x. But in here, I prefer to eliminate x, then solve for y. To eliminate x and to solve for y, okay, we will be multiplying equation number 1 by 2. Okay, so the coefficient of x on the first one will now become 10. Okay, and for equation number 2, I will be multiplying this by 5. So again, if we try to expand this one, the resulting coefficient of x will again be 10. Okay, so if we try to perform the operation subtraction, this is 10x and this is 10x, and if we try to perform subtraction, we will eliminate x and we can solve for y. Okay, let's continue. So multiplying equation number 1 by 2, this will become, we expand this one, right? This will become 10x, 2 times 3y will be 6y, 2 times 19 will be 38, and we will call this equation 1a. It is 1a because the coefficients are different from equation number 1. So for it not to be equal to equation number 1, I call it 1a. And for equation number 2, we will multiply all the terms by 5. So this is 5 times the quantity 2x minus 5y equal to 11. Expanding this one, this will become 10x. 5 times negative 5 will be negative 25y. And 5 times 11 will be equal to 55. And we'll call this equation number 2a. This is similar to equation number 2 except for the coefficients. That's why instead of naming this as equation number 2, I put it 2a. Then I will try to rewrite equation 1a underneath. Right? So rewriting equation 1a, this will be 10x plus 6y equal to 38. It emanates from this. Okay, then I will try to perform the operation subtraction. This is subtraction, right? So 10x minus 10x, this will now be negative, right? 10x minus 10x will be 0. Okay? Minus 25y, the operation is subtraction. This is plus 6y, but the operation is subtraction, so this will now become negative 6y. Just be careful on the sign, because if you made one mistake on the sign, the solution will be wrong. Okay? So this will become negative 6y. So this is negative 25y, negative 6y. So we are adding two negative terms. So we will just add the exponent. Okay? But since the sign is negative, this should be negative 31y equal to. For the right hand side, it will become 55 minus 38. So this will now be negative 38. Right? So 55 minus 38 will now be equal to 17. The first term is actually 0 now, because by multiplying this by 2 and 5, we eliminate x. That's why I prepared that I will eliminate x, then solve for y. Okay? So negative 31y equal to 17, or y will be equal to negative 17 over 31. Okay? It's a fractional number. And to solve for x, since from the two given linear equations, equation number 2 is more simpler, I prefer to use equation number 2 in the computation for the value of x. So following this equation here, 2x minus 5 times the computed value of y equal to 11. 2x now will be equal to, this is a negative and a negative, this will now be plus. 5 times 17 will be 85 over 31, and this should be equal to 11. Again, from the rule of the solution of the linear equation, we will maintain the unknown on the left-hand side when we transpose all constants to the right. So we will transpose this to the right. So this will now be equal to negative 85 over 31. 2x now will be equal to, we'll combine this one. Right? So the resulting equivalent will be 11 times 31 will be 341 minus 85, all over the common denominator 31 now. Okay? X now will be, the difference will be 256 over 62. I think 62 is 31 times 2, right? So we place 2 here. So no more 2 here. So that will be 62. But 256 is divisible by 2, so it will become 128, okay, over 31. So the value of x will be 128 over 31, and y is actually negative 17 over 31. So this will be the solution of the two given linear equations. To check the validity of the answer, since the answer are in fractional terms, okay, let's try to check it. We might be wrong. We might have made some mistakes on the simplification, so we must have to check. So by using equation number 1, since we use equation number 2 in the computation for x, we will be using equation number 1 for the checking. So following this, 5 times the computed value of x, 128 over 31, plus 3 multiplied by the computed value of y, which is negative 17 over 31, will it be equal to 19? 128 times 5 is 640, and 17 times 3 will be negative 51. This is all over 31, this is all over 31, so we could combine now. And 640 minus 51 will be 589 over 31, and will it be equal to 19? And luckily, 589 over 31 is really 19. So 19 is equal to 19, it is true. So our solution for the given system of linear equation will be x equal to 128 over 31, and y will be negative 17 over 31. That's the solution by using the so-called elimination method. Okay, guys, this is just a refresher for you guys. Okay, for those who are taking up CET or ACET, it's an easy one. what is important is actually the concept. Okay, for those of you who would like to follow my channel is at youtube.com/Prof. David J. De Los Reyes. If you want to share it, please click share. Good morning from Los Angeles, Professor David J. De Los Reyes.